Cosmic glitch theory. The universe hides a secret. It's not a distant monster or a lurking black hole. It's a flaw, a vulnerability woven into the very fabric of existence itself. A theoretical glitch so violent, so absolute, that it wouldn't just destroy our world, it would erase the rules that allow a world to exist in the first place. This isn't an explosion that happens space, it's an explosion space. A silent, unstoppable wave of change that rewrites reality, boiling space-time and deleting everything we are, everything we were, and everything we could ever be. This is the theory of vacuum decay, the universe's ultimate self-destruct sequence. And the terrifying part is, it could be triggered by a single, random event anywhere at any time. To understand this cosmic apocalypse, we have to throw out our conventional ideas of empty space. We think of a vacuum as nothingness, but in quantum field theory, it's the exact opposite. The vacuum is a seething, vibrant arena of potential. It's the ground state, the lowest possible energy level for everything. Imagine the entire universe is filled with invisible fields, one for electromagnetism, one for the strong nuclear force, and so on. The famous Higgs field is one of these, and its job is to give fundamental particles their mass. These fields are like vast oceans, and the particles we see are just ripples or excitations in them. For our universe to be stable, truly and eternally stable, all of these fields must be in their lowest possible energy state. This is called the true vacuum. It's the ultimate cosmic bedrock, the point of absolute rest. But what if our universe missed? What if, in the chaotic moments after the Big Bang, the universe cooled and settled not into the lowest possible energy state, but into a slightly higher one? Imagine a broad valley with a small dip on the side of one of the hills. If you place a ball in that small dip, it's stable. It won't roll out on its own. It's in a state of equilibrium. But it's not in the stable state, which would be at the very bottom of the main valley. This precarious, seemingly stable dip is what physicists call a false vacuum. Our entire universe, with all its galaxies, stars, and life, might be living inside one of these cosmic potholes. It feels stable, it acts stable, but it's fundamentally fragile. All it needs is one good push to send it tumbling down to the true, lower energy state at the bottom of the valley. That push is where the glitch comes in. It wouldn't be a physical shove, it would be a quantum one. Through a process called quantum tunneling, there's a tiny but non-zero probability that a small region of space could spontaneously tunnel through the energy barrier separating our false vacuum from the true vacuum. In an instant, a microscopic bubble would form, a bubble of true vacuum. Inside this bubble, the universe would be different. The fundamental properties of reality, dictated by the energy levels of those quantum fields, would be radically new. The Higgs field, for example, might have a completely different value. This would change the masses of all fundamental particles. The strength of forces like electromagnetism could be altered. The very possibility for atoms to form stable structures might vanish. It would be a new universe with a new operating system, and our current one would be completely incompatible. This is where the true horror begins. This bubble of new physics doesn't just sit there. Because it's in a lower energy state, it is inherently more stable than its surroundings. It would begin to expand relentlessly in all directions. And the speed of this expansion would be a breathtaking, inescapable constant, nearly the speed of light. A perfect sphere of absolute change, growing from nothing, consuming our reality as it goes. There would be no warning. No telescope could ever see it coming, because the information of its approach, light itself, travels at the same speed as the wall of destruction. One moment, the Andromeda Galaxy is 2.5 million light-years away. The next, it's gone. Not because it was destroyed, but because the space it occupied has been fundamentally rewritten into a new form of existence. Then the space a light-year from Earth is rewritten. Then a light second. Then, in the final instant, the wall of the bubble arrives. The encounter would be absolute. It's not about heat or pressure. It's a phase transition of reality itself. Think of supercooled water, which can remain liquid below its freezing point. It's in a false, metastable state. But introduce a single ice crystal, a seed of the true state, and the entire body of water instantly flashes into solid ice. Our universe is the supercooled water, and the bubble of true vacuum is that first ice crystal. As the boundary of this bubble passes through you, the very structure of atoms would become impossible. The electrons, protons, and neutrons that make you up would either cease to exist or be transformed into something utterly alien, governed by new laws of physics. Your consciousness, your memories, the electrical signals in your brain, all would be extinguished in an instant, not just destroyed, but erased from the pattern of reality. It's a fate more final than death. It is the deletion of the very possibility that you ever were. This isn't just an apocalypse for humanity. It's an apocalypse for physics, for chemistry, for existence as we know it.
Boiling Spacetime explained. So, we have this unstoppable bubble of new physics, expanding at light speed, ready to overwrite our universe. But what does that actually mean? What happens at the boundary? The phrase, boiling spacetime, isn't just a dramatic flourish. It's an attempt to describe a process of such extreme violence it beggars belief. The key is the energy difference. Our universe, sitting in its false vacuum state, has a certain baseline energy density. The true vacuum inside the bubble, by its very definition, has a lower energy density. In some models, it could even be negative. When the universe transitions from that higher energy state to the lower one, the difference in energy has to be released. And the amount of energy we're talking about is almost incomprehensibly vast. It's the potential energy of the entire universe, unleashed all at once at the surface of an expanding sphere. This surface, the wall of the bubble, would become the most energetic phenomenon in the cosmos, far hotter and more energetic than the core of any star or even a supernova. As this wall of pure energy slams into matter, a planet, a star, a galaxy, it doesn't just burn it or blow it apart. It triggers a fundamental conversion. The particles that make up our reality are, in essence, stable configurations of quantum fields. When the bubble wall hits them, it's like dropping them into a furnace that operates on the source code of physics itself. The energy is so immense, it would vaporize particles into their constituent quantum fields, dissolving the very idea of matter back into raw, chaotic potential. This is the boiling. It's a phase transition where the familiar states of matter, solid, liquid, gas, plasma, are completely irrelevant. We're talking about a transition of existence itself, a chaotic, high-energy frothing of the fields that underpin reality. The fabric of space-time in the immediate vicinity of the wall would be warped and twisted by this incredible energy release, creating extreme gravitational waves, ripples in reality itself. And what about inside the bubble? What would this new, true vacuum universe be like? The honest answer is, we have no definitive idea, but the theoretical possibilities are grim. With the fundamental constants of nature altered, the new reality could be profoundly boring. If, for example, the Higgs field's new value made elementary particles drastically heavier, gravity might be so overwhelmingly strong that the universe would immediately collapse in on itself in a big crunch. Or, if the forces that bind atomic nuclei were weaker, no elements heavier than hydrogen could ever form. There would be no stars, no planets, no chemistry. It could be a dead, sterile cosmos where nothing interesting can ever form. A universe of simple particles and weak forces, incapable of generating complexity, let alone life. Our universe, with its delicate balance of constants that allows for stars, galaxies, and consciousness, might be an incredibly fortunate statistical fluke, a temporary state of being that is destined to be flattened into a more stable but utterly lifeless reality.
This all leads to the one question that truly matters. Are we in danger? Could this happen right now? The answer is a fascinating and slightly unsettling, probably not, but we can't be 100% sure. Scientists at the Large Hadron Collider have been meticulously measuring the properties of fundamental particles, specifically the mass of the Higgs boson and the top quark. These two values are critical in calculating the stability of the Higgs field, and therefore the stability of our universe's vacuum. The current data suggests our universe is in what's called a metastable state. This is the scientific term for the ball sitting in that small dip on the side of the hill. It's not truly, eternally stable, but it's stable enough that the odds of it spontaneously tunneling into the true vacuum are astonishingly low. The calculated lifetime of our false vacuum is many billions of times longer than the current age of the universe. So we are almost certainly safe from a random spontaneous event. However, spontaneous is the key word. Could something it? This is a topic of debate. Some early concerns suggested that high-energy particle collisions, like those in the LHC, could create enough energy in a small enough space to tip the universe over the edge. However, extensive calculations have shown this to be virtually impossible. Nature already provides us with cosmic rays, particles that travel the universe and collide with energies far greater than anything we can create on Earth. Since the universe hasn't been destroyed by one of these collisions in 13.8 billion years, our own experiments are considered safe. So why do cosmologists and particle physicists even spend time on such a terrifying, seemingly remote possibility? Because it's not just about predicting the end of the world. Studying the stability of the vacuum is a crucial stress test for our most fundamental theories, like the Standard Model of particle physics. If our best theory of the universe predicts its own potential demise, we are compelled to understand every detail. It pushes us to refine our measurements and search for new physics that might stabilize our vacuum. It also gives us profound insight into the very early universe, which likely underwent several phase transitions of its own as it cooled after the Big Bang. Understanding this potential future transition helps us decode the story of our cosmic past. Ultimately, the theory of vacuum decay is a stark reminder of our place in the cosmos. We live in a universe that appears robust and eternal, but which might be balanced on a knife's edge of quantum probability. This cosmic glitch, this violent secret, represents the idea that our entire reality is a temporary phase, a lucky accident. And while the bubble of true vacuum is unlikely to appear tomorrow, its theoretical existence forces us to confront the ultimate fragility of everything we know. It is the universe's silent, final threat, hidden in the quiet of empty space.